Hello, ladies and gentlemen. I hope you are all doing well and feeling fine. We're looking at our last problem, problem number 5, on our 2018 Alberta High School Contest Part 2. Triangle ABC has angle BAC equal to 80 degrees and angle ACB 40 degrees. So we might try and draw this triangle before we go any further. I might say something like A, B, and what were the angles? I think the angle at A was 80, so it's going to be kind of steep. And then AC, so C, I don't know, we'll place it up here, and then 40 is kind of narrow, so we'll say something like that. Okay, so there's our nice little picture. 40 up here, 80 up here. Those add up to 120, so that leaves over, a 60-degree angle. Oh, interesting. Probably something worth commenting. Angle ABC is 60 degrees. 60 degrees is always nice because we might start thinking 30, 60, 90 triangles. Although I don't see a lot of those here. I do see 40, 60, and 80, which is an arithmetic sequence, but anytime you've got an angle of 60, you're going to have an arithmetic sequence. Okay, and then D is a point on ray BC beyond C. So actually, I drew this too tall, I guess. So A here, C here, B here, A, and then they're saying D is somewhere on this ray. So that CD is the perimeter of the triangle. Okay, so this is CA plus, what was it? AB plus BC plus CA. Okay, so we've got that. We've got these angles here, 40, 80, 60. Find the angle of ADB. Okay, so we started with a nice triangle whose angles were specified, so that's a nice fixed thing. Based on the perimeter, we extend D out here, and then so we want to connect these up, and I want this angle. So I better get something that, no, was it at A? No, it's at D. So I want this angle here. Although maybe we will need that other angle on the way. So that's, we're looking for this angle right here. So, we don't have any side lengths, so I'm not of the opinion that we would need to do any sine law or anything like that. The other reason I don't think sine law might come into play is just because I don't know sine of 40 or 80 or that they have a nice particular relationship. Sine 60 is a very nice number, but if I was seeing something like 30 and 90, we wouldn't even need trig at that point. But sine 40 and sine 80, I mean, one is double the other, is maybe important, but we'll see what we can do without trigonometry. Okay. So I noticed that A, B, and D as a triangle still has this 60 degree. Is that going to be useful? Is that going to be helpful? Well, whatever this x triangle is, maybe call it x, add it to 80. It along with y is going to have to be x and y have to add up to 40, but of course we knew that because there's a 40 right here. So I'm not seeing anything initially that jumps out at me from this particular diagram, so we need to start using the facts that they gave us. Now, they didn't give us that it's 60, but we quickly worked that out. But I'm more interested in this, the fact that CD is the perimeter. And it was CD, not BD, right? Yeah, CD is the perimeter. So that means, and there's going to be lots of different ways to do this, but that means we could come along and pick 2 points on here and have, this be length AB, and this be length BC, and this be length CA. Or we could come along and, mark them another way and have this be BC, and this be CA, and this be AB. We can, there will be points along there that we can do that. So there's that relationship. And actually, now that I've got that drawn in there, this CA, so we might say something like that AB on CD, so CA is equal to CE, and then we've got a nice little triangle here, and this is an isosceles triangle. And I know what its interior, these two angles will be the same, and they have to add up to 40, just like these two angles had to add up to 40, because we've got an exterior angle to our triangle here. So these will have to be 20. And so X here is actually bigger than 20, and it's got a nice little, we call it Z in here. Z and Y now have to add up to 20. So whatever answer it is, it has to be strictly less than 20. That's something. I want to maybe zoom in a little bit. I think there's not really going to be a nice way to scale and draw this picture, but it worked out pretty nicely, actually. So we get 20 here, you get 20 here. And you'd have to actually say, triangle ACE is isosceles. So therefore, CAE is CEA. And they're both going to have to be 20. This is not a big calculation to make. And depending on who's marking, you could just state it. Or you could show it. We've got a nice little 40 here. Okay, so we've got that. Now, so going back to the bigger scale picture, is there any point in picking one of these to be this point and adding and attaching it? Well, no, because I don't quite know what this side is, although there might be some sort of similar triangle work and shows that this happens to be CB. Actually, I don't think it can be CB, but got this 60 degree here. I'm going to pick point F here, make a nice little inside equilateral triangle, and I'm also going to extend AB to G, and we'll get rid of this work here. We'll say this is G down here, and make this a 60 degree, an equilateral triangle. So we'll place F on BC, so that triangles AFB and GCB are equilateral. So this is a way to make use of this 60 here. Okay, and this is, I think, going to get a little confusing, so I'm going to make these same sides red. I've got this side here is blue. Anytime I use blue, and then we'll make the long side green. And when I color code like this, things like isosceles triangles can jump out at me, or if we see a triangle with blue, green, and red on its sides, then we know it's congruent to our original ABC. We might be on a hunt for similar triangles, isosceles triangles, equilateral triangles, congruent or similar triangles. We don't quite know. Now, I've got this 20 here, and if this is 60, then this is 20 degrees as well. So we actually have another little isosceles triangle hidden in here. So that's kind of cool. We might call this point of intersection H. Right now, we're just playing around with it, but if you feel like you're about to run out of time, remember it's a 3-hour contest. You can be writing what you're doing as you go along, even if you don't quite have a set plan in motion. I'm going to draw this blue here, because a terrible looking solution that isn't refined and well written is still better than no solution at all. Okay, so if you stumble your way to an answer, that's okay. But you should always, if you've got time, go back and write it up nice and neat before submission. Okay, so we've got a 60 here, a 60 here. Now this whole thing was 80, so we're going to get a 20 in here. Now wouldn't it be nice if this were 20 as well, but it can't be because this angle and, I guess we called it Z, and the Y up here have to add up to 20, so can't be 20. Might not even be an integer, we don't know. But we might be looking for more isosceles triangles at least. If those two are 20, then we get a 40 here. And this is a 60, so this will have to be 80. And then if we take a look, I'll highlight it in pink. This triangle here, AGH, is similar but not congruent to A, B, C. Gotta make sure the letters line up in the same order as their angles are present. Okay, so both H and C are at the end because they're the 40-degree ones. So we might start looking for other copies, smaller copies of this. I'm seeing a lot of 20s. Makes me think that there's a reason they gave me 40, 60, 20, and the arithmetic sequence there, they all differ by 20 degrees. Is there anything else that we can see that might immediately jump out at us? Or is there anything we can see that might lend itself nicely to making another isosceles triangle? Or maybe if we start chopping things up in terms of 20s again. Well, not again. I mean, we just happen to have some 20s lying around. Well, let's fill in a few more of these angles. This here will have to be 40 because it's opposite that 40. This will be 140. Complete the 180. This is 120. Not seeing anything right away, and certainly nothing that is getting me this angle here. Now, it really looks like if I sort of extend H down here, I could make a 20 and a 40 here, but there's no guarantee that extending that ray actually hits H. And it's probably just my sloppy picture. That's a lot of angles. Nothing really jumps out at me as something to focus on right now. Another 120 here. Oh, these two are... I think at least congruent, if not... Or sorry, at least similar, if not congruent, but let's see. Yeah, the 120 is opposite the blue side, but the 120 is beside the blue side up here. But the two yellow ones are congruent, or similar. Similar. Why do I keep saying congruent? And is there any sort of special relationship that we can see here? I like that the pink triangle is similar to our original one, but I don't see any decent way to get... Like, it'd be nice if I could get this angle in here, because that would get me the angle we called Z, and therefore we'd have the angle Y. And maybe I need to broaden out a little bit. I mean, all I've used is the fact that CA and CE are the same, but I haven't used the rest of that perimeter being implied. I don't know how to get this angle. Sadly, it's part of a bigger quadrilateral, although maybe it's cyclic. I don't know. We could check for something like that. How would you check for it to be a cyclic quadrilateral? I suppose if it were cyclic, that would have to be 120 because it's opposite the 60. So obviously, that's not the case. Although maybe there's another cyclic quadrilateral somewhere in there. So you can recognize a cyclic quadrilateral, just while I'm thinking about talking about them, if opposite angles add up to 180, or you can recognize that the 4 points are on a circle if 2 of the points subtend the base at the same angle. And really, that's the same thing that's going on here. We just have they're subtending the same line from opposite sides. So instead of getting the same angle, you get supplementary angles. But I'm not seeing anything that should be a cyclic quadrilateral. I'm not even seeing anything that I might want to draw as a circle. So what success have we had? Well, really it was just this isosceles triangle, so maybe we want to hunt for more isosceles triangles. We saw this one in here, and it's also with 20 degrees, and that makes me think maybe I do want... Maybe there is some reason why H should connect up there, so we can try that. So and E, C, A is here, B is here. 40 here, we got 20 here, 20 here. Now there will be some point, what are we up to? We had H, let's say I, so this is point I. So pick I on AE so that IBE is 20 degrees. That gets me another isosceles triangle. So this becomes 20, this becomes 40. And then these two are the same length. This is the same length, so those are similar. But not really seeing this as particularly helpful. So this is an 80 down here. 20 and 80 makes 100, so this angle in here, so if that's 40, this has got to be 60. Well, there's another copy of our triangle. right? And then 20 makes 60, so this would have to be 40. So there's another isosceles. Oh, this one actually is color code the sides this time. So that's nice. And that puts EA is another part of our perimeter. I wonder, is this going to be the other side, and then we'll get another isosceles. So it looks like isosceles triangles might be the name of the game today. So I would need to show that this and this are the stuff. So if I could get another isosceles triangle sitting here, if I could show that CIB is isosceles, then BC would be BI, would be IE, and that would do it. That would get me another isosceles triangle, and so my answer would then be 10 here and 10 here. But we're getting ahead of ourselves. Maybe that might not be the case. That's just wishful thinking. But it really looks like it goes together there, thanks to this redder isosceles triangle. So, is there a way to show that BCI is isosceles? So with the 20 there, we would need what? 80. So we would need a 40 here and an 80 here. Ah, but we've got a 60. Nah, no. That's starting with what I'd like. So I know there's a 60 there, but I don't necessarily know that one of those is 40 and the other one's 80. All I know is that these two add up to 120. Okay, we don't want to do bad math. We don't want to assume something. I would like for the check to be 40 and the dot to be 80. Is there a way to show that? It looks like I connect CI. This might be something worth noting. Yeah, it's got that sort of, yeah, it's got the nice little butterfly pattern. Usually when we're doing a geometry question, I recognize a cyclic quadrilateral with this sort of butterfly pattern. So I know I said not a moment ago that you recognize cyclic quadrilaterals because opposite sides add up to 180, or you recognize cyclic quadrilaterals because you get same angle subtending a base, which I guess we do have. But I find in practice more the way I recognize cyclic quadrilaterals is not that they're actually a quadrilateral for me to see, but that I more have this little butterfly shape, and that it's the same angles here and here, and that's what we've got, 40 and 40, 20 and 20. So ABCI is cyclic. Does that do anything? Yes, because this is a 100, so this has to be 80, and that means this would have to be 80 as well. Okay, there we go. I think everything fell into place. So we pick I on here. So, I mean, all this was interesting with the 60 degrees and the equilateral triangles. I don't think it really goes anywhere. It did motivate me to think maybe H was here, and that might be the case. I don't think H is here. I think H and I are actually in different spots. But it did motivate me to start looking at quadrilaterals because this was kind of messy, and I really wanted to split this up. But the fact that we found the isosceles triangle here, and we had started with this isosceles triangle here, it's what's best. But ultimately, we don't need anything on this page. We can just say, okay, make E so that this happens. You get these 20 degrees here. You get that conclusion. And now we jump in here. Pick I on AE so that this happens. Okay. AIB and ACB are both 40 degrees. Or you could say that it's just the way I've drawn it here, that I and C are sort of subtending this base AB. But you could easily point out that B and A are subtending IC. Either way is fine. Then we conclude ABCI is a cyclic Quadrilateral. Okay, so we'd point that out. Now, angle EAB is angle EAC plus angle CAB, which is 20 plus 80, so it's 100. And then you point out opposite angles in a cyclic quadrilateral are supplementary. That is, they add up to 180. Supplementary or complementary? Supplementary, I think it is. Complementary, I think, is when they add up to 90, which is important with trigonometry. So the opposite angle, so BCI is 180 minus BAI, which is 180 minus this angle EAB. I guess we could write it up a little nicer. We can make the B's not change position, so 180 minus 100. So we get 80 degrees here. Okay. And since we chose I, so that IBC is 20 degrees, and as a result, IBA is 40 degrees, which we'll use in a moment. How did we get the 40 here? So I had a 40 here. How did I know this is isosceles? I don't think oh yes, because this is 100. There we go, that's why. It's 100 and a 40, so it had to be a 40. You probably need that conclusion in here somewhere. So say something like AIB is 180 minus IAB, which we just commented was 100, minus IBA. Okay. Kind of make sure everything follows and that you haven't just made something up or made a leap of logic that somebody can't follow. Okay, so since we chose IBC so that happened, we conclude CIB is 80 degrees as well, because it's 180 minus 20 minus the 80 we just worked out on the last page. So CIB is isosceles. It really was all about isosceles triangles. So IB is equal to CB. Okay. And since they're both 40 degrees, we also know that IBA is isosceles. So IA is the same as AB. And EIB, the whole reason we did this was so that I could get an isosceles triangle here. That's the whole reason we did this 20. So this is also isosceles, so IB is EI. And so our conclusion from these two, and then this one, is EA is EI plus IA, which is CB plus, well, let's say AB plus BC, keep it in the same order. Okay. Now going back to our big picture, we realize why they put the perimeter in there in the first place. We have our 20 degrees here. We have blue. I think it was red down here, and so red here. This is green, this is green. It doesn't really matter the order, I'll keep them the same, so green and then red. This is D. So DE is the same as EA. So DEA is isosceles, and therefore DAE equals ADE, and so they need to add up to 20 degrees, so they've got to both be 10 degrees, and we wanted this angle. No, we wanted the angle up at D, yeah. So therefore the angle at D is 20 degrees. There we go. It turns out it was an integer. That's kind of nice. And we didn't need to resort to trig, although there could very well be a trig way to do the question. As I said at the start, I don't think there is. Or if there is, it's a little messy because of the 40 and the 80. But the fact that we started seeing everything sort of differing by 20 around there, and the isosceles triangle that I spotted with the perimeter was really nice. I think those are the two things that sort of clinched it. Seeing this triangle here and making this triangle because I saw the 20s and the 40s and the 60s and the 80s. So always pay very close attention to the numbers that you've got. But other than that, if you see those two things, you really start thinking isosceles triangles, and we just kept using them. So we had one isosceles triangle here, one here, another one in here, and another here. So 5 isosceles triangles. But if you didn't see them, this could have been something that you really sort of raced around chasing angles about a whole lot. But there we go. So that ends our part 2 paper. So that's it. So, if you had a different way of doing problem 5 or really any of the problems, by all means, let me know. I'm always interested to learn different approaches, different thought processes for questions. But I think that's it. If you're looking for more Alberta contests, feel free to browse around the channel. I should have some up. But other than that, take care and have yourself a wonderful day.